Hello students. In this tutorial, we will now program our robot to turn precise distances. You will need a meter stick and your robot for this tutorial. If you measured your robot already, it may help to have your measurement note page with you as well. Turning precise distances right or left. There are also times when we need our robot to turn precise distances. For example, during your final project, you may need your robot to do a quarter of a turn to face a new direction before continuing its journey. Just like with forward and backwards, there is no way to put a precise turning distance into our programming software. Remember, the degrees option tells your tire how many degrees to turn, not how many degrees your robot will turn. So again, we must convert the distance we want the robot to travel into the degrees that it will require the robot's wheels to turn. Only then will you be able to tell your robot exactly how far to turn before stopping. The robot calculator spreadsheet can again be used to do the math for you. Open the robot calculator file on the Google Classroom. Please note, the blue part cells at the top of the file will be used to make your robot go straight, forward, or backwards. The purple cells at the bottom of the document will be used to make your robot turn. Scroll down to where the purple section begins. Step 2. We will now fill in the robot's measurements, purple column. Measure the diameter of your tire, round to the tenths, type in your answer in the calculator. Just like before, it is easiest if you take the tire off to measure it. So I take it off and set it directly on my meter stick. We're measuring from the end across the center to the opposite end of your tire. So be the widest part of your tire. I'm going to make up a number for us. It will calculate the circumference for you. You do not need to do anything with that number at this time. Step 3, count the number of teeth on gear number 1, which is either on the motor or closest to the motor. Then count the number of teeth on gear number 2 off the motor. Type these values in your robot calculator. The calculator will calculate the gear ratio. If there are no gears, then your gear ratio is 1. You do not need to do anything with that number at this time. If we look at our robot, if we look by the motor, there's no gears on here. So I would just put 0 here. And again, that will calculate my ratio to be 1. If you had gears on your robot, they do show you what they look like in the instructions. It looks like a circle with these little pointy things sticking out. Those are the teeth. So that's what you would be counting if you had gears. It should be an even number. Step 4, measure the wheelbase of your robot, the distance from the center of one tire to the center of the other tire. Again, round to the tenth. The wheelbase is essentially how wide your robot is. To do that, I hold the meter stick up to the center and again, look over to where the center of my other tire is. Like before, I'm going to make up that number, but you aren't just copying mine. Step 5, the calculator also needs to be told how much your robot will be turning. Please remember that there are 360 degrees in a circle. You can find the number of degrees you are turning by multiplying 360 to the fraction of a full turn you are doing. For example, a quarter of a turn would be 90 degrees because 360 times 1/4 equals 90. And a half of a turn would be 180 degrees because 360 times 1/2 equals 180. Your notes also has a image here that shows some of the common turning degrees for our robots. I'm going to turn halfway around to face the complete opposite direction, so we will call that 180 degrees, which is already in here. Step 6, hit the Enter key on your keyboard. The calculator will now do its calculations and tell you how many degrees the robot tires will need to move for both a point turn, that'd be the amount you would need, and for a swing turn. Notice they are different amounts. Just like before, you want to make sure you don't accidentally delete or change any of that formula or you will get the wrong calculations. Because the turn left and turn right method is the only one that has the option to put in real degrees, it means your robot must do a point turn if you are trying to turn a precise amount at this time. Eventually, we will learn how to program swing turns for degrees as well. Write down the number of degrees needed for a point turn. So this 822 is the amount you're going to need. Step 7, open up your Robot C programming software and add a turn right or a turn left block, like we've done here. Step 8, change the unit you are counting in to degrees and plug in the number of degrees you found in the robot calculator. So we said 822. You should always leave the speed at 50 when using the robot calculator in order to get the most precise results, or you can make it even slower. Step 9, optional. You can now add any other directions underneath here. Step 10, select download to robot. Make sure you've hit the orange power button to turn your robot on and that it is plugged in. Once I download that, I should see the robot of this size turn halfway around to face the opposite direction. When the example is done, you want to scroll down to where our practice problems are, and then your final project is also listed here as well. So your task, tell your robot to turn right 45 degrees at a speed of 10, then continue turning right 315 degrees at a speed of 80, then tell your robot to immediately turn left 360 degrees at a speed of 50. Finally, have the robot turn right 15 degrees at a speed of 15.